Campaign 5A is the first campaign for the environmental impact assessment. This is the Benthic part of the campaign. We've got a number of research institutions from Leeds University, the University of Gothenburg, Natural History Museum and Florida State University, who are doing various studies on the bottom sediments and the nodules. There's four main components to Campaign 5A. The first component is the box core work, which is designed to investigate the biota of the sediments and the nodules. The second component is the multi-core work, which is designed to investigate the biochemistry of the sediments. We also have hydrophone deployments, which is designed to pick up ocean noise, particularly clicks and squeaks from cetaceans such as whales and dolphins. And then we also have a surface biology component, which is visual identification of surface animals.
We have a green light to recover all the way to deck.
Deck copy, green light.
So in this Benthic campaign, we're using the multi-corer to collect undisturbed seabed sediment samples. Getting undisturbed seabed sediment samples back onto the vessel is actually quite a big challenge. First of all, the seabed is 4.5 kilometers underneath us. The multi-corer doesn't have any propulsion, so its position is solely determined by the vessel above it. We then have to set it down really gently on the seabed to avoid disturbing the sediment-water interface. And then finally, we have to remove it from the seabed and bring it back to the deck of the ship without disturbing the sediment inside the cores, so they naturally represent the seabed physically, chemically and biologically.
I'm leading the environmental DNA sampling as well as the foraminiferal community sampling. And with that data, we are looking to establish these environmental baselines prior to marine mining. eDNA stands for environmental DNA, and it's based off the notion that all living things release DNA constantly. It gets entrained in a certain area, and you can take an aliquot of that either sediment or water and run it for genetic sequencing and get an idea of the immediate community surrounding that section of sediment or section of water.
I'm part of the geochemistry team on board. We're doing measurements of oxygen and alkalinity on board, but then we're taking more samples to take back to the labs, back at Leeds and the other universities in order to quantify metals, nutrients, organic molecules and other things that will help us understand this environment more.
Here on Maersk Launcher, I'm here to identify the animals we get from the box core, from the seafloor. On this cruise, we are dividing up samples between Natural History Museum in London and my university, University of Gothenburg in Sweden. So when we get back home and get the samples, we're gonna open the tubes again, pour out the animals and look at them more closely and try to identify them properly.
For us being here, it's a great opportunity in terms of getting samples. So far we've collected like 3,000 animals, and these are samples that we're going to access into the scientific collections at the Natural History Museum, which has some of the largest scientific collections in the world.
I'm excited to be part of this environmental baseline study to, ensure that ecological quality status be monitored before, during, and after test mining.
It's a really good opportunity to get out here just in the middle of the Pacific to actually investigate the seafloor, because these chances don't come across very often.